Hello friends, welcome to Ashok IT. In this video, we will be seeing Java collections and this video will be like a crash course for Java collections. So in this video, we will be covering what is collection, why we use collections and collection framework advantages, arrays versus collection and collection framework overview. And we will be seeing the list, set and queue interfaces with examples, also map with examples, the cursors which are used for traversing the collections, that is iterator, list iterator and enumeration, and comparable versus comparator interface. So collection framework has been defined in JDK 1.2 and it holds different collection classes and interfaces in it. So many collection classes and interfaces are present in collection framework. And in the collection framework, the collection interface and the map interface are the two main interfaces. And it provides an architecture which will allow us to store and manipulate the group of objects. So we use collection because it provides architecture to store and manipulate group of objects. So for storing and manipulating the group of objects, the collection framework is used. And the storing and manipulation of group of object is done using the different classes and interfaces of collection framework. So collection framework provides many important classes and interfaces to collect and organize group of similar objects. Interfaces in Java collection framework refers to the abstract data types, which allow Java collections to be manipulated independently from the details of their representation. And classes in the collection framework are the implementation of interface. And it refers to the data structures that are used again and again to store the data in the form of objects. And the advantages of collection framework are it reduces programming effort, it increases the performance, it provides interoperability between unrelated APIs, it reduces the effort required to learn APIs, it reduces the effort required to design and implement APIs, and also it fosters or helps in software reuse. Now let's see what is the difference between arrays and collections. So arrays are fixed in size and they do not allow to increase or decrease the size. So based on our requirement, we cannot increase or decrease the size of array at runtime, whereas collections are growable in nature. And based on our requirement, we can increase or decrease the size at runtime. And arrays can hold both primitive as well as object types, whereas collection can hold only objects but not primitive type of data. Arrays can hold only homogeneous elements, that means same type of data it can hold, whereas collection can hold both homogeneous and heterogeneous elements, same and different types of data. And for any operation requirement, there is no predefined method available in case of arrays. There are no predefined methods available which can be used on arrays. But in case of collection, there are many predefined methods available which can be used for operating on the objects which are stored using the collection classes. So there is predefined method support available in case of collections. Let's see the collection framework architecture. So the topmost interface in collection framework architecture is iterable, which is implemented by collection interface. And the collection interface is implemented by list interface, queue interface, and set interface. Then the list interface is implemented by ArrayList, LinkedList, vector, and stack. And the queue interface is implemented by DQ interface, which is then implemented by ArrayDQ. And also the queue interface is implemented by PriorityQueue. And DQ interface of queue interface is also implemented by LinkedList, which is also implementing list interface. So LinkedList here can behave like a list and also a queue. Set interface is implemented by HashSet, LinkedHashSet, and the interface sorted set also implements set interface, which is then implemented by TreeSet. Other than this collection interface. We also have the map interface under collection framework. So map interface does not implement collection interface. It is a separate interface which is implemented by HashMap, LinkedHashMap, and sorted map, which is an interface which is then implemented by TreeMap. So the classes which implement map are HashMap, LinkedHashMap, and TreeMap. So this is the architecture of collection framework. So here list, queue, set are the interfaces which implement the collection interface, and map is a separate interface which belongs to collection framework but does not implement the collection interface. Let's first see about the collection interface. So the first interface which implements collection interface is list interface, which is then implemented by again ArrayList, LinkedList, which also implements DQ interface of queue, and then vector and stack. So first practically we will be seeing ArrayList, how to store objects in ArrayList, and how to use in Java program the ArrayList class of collection framework. So for that I will be using the Eclipse IDE. So here is the Eclipse IDE, in which I have already created a project by name collections, and then I have added a Java file by name test, and the class name here is test, inside which I have the main method present. So within the main I will be here creating or using the ArrayList class of collection framework. So here the ArrayList object we need to create for the ArrayList class, which I am creating as AL. So like any other class for this ArrayList also I am creating object, and we can use this ArrayList after we import the Java util package, because all these collection classes are present in Java util package. So for that we need to import Java util package ArrayList class. So after we import this, we will be able to use the ArrayList class from Java util package. So here we made a spelling mistake. Yeah. So this is the object creation for ArrayList. Now what type of objects you want to store, that we can give using the wrapper classes, which we will be writing within the angular bracket beside the class name. So if we want integer type of data, then within angular brackets, integer, which is one of the wrapper classes for integer type of objects, we will be using. So here I am mentioning the type as integer within the angular brackets beside the class name. And to add elements to this array list, I will be using the object which we have created, dot. The predefined method add can be used, or add index and the integer we can use. So I am here using add, and any integer value we can assign. Similarly, I will be adding 4 more, like here 4 items I have added. Now to print it, I am using system.out.println, and here I'm just printing the AL object, which will print all the values of this AL object. So when I execute the program, I will be getting in the set format this elements of array list. So this way we can create array list which implements the list interface of collection framework. So we have seen the practical explanation for ArrayList, that is practical program of ArrayList, where we have created ArrayList with 4 integers, and we also printed the object which we created for ArrayList. And then let's create linked list. Like we have created ArrayList, same way we can create the linked list also. So again, for using linked list, we need to import the Java util package linked list class. So I am creating linked list object as LL, and to use it, we need to import java.util package linked list class in this manner. And the type, similarly like in ArrayList, we can mention using the wrapper class. So same way like how we created ArrayList and added items, same way we can add items to all the collection classes. So add is the common method which is present in collection interface. So as all the classes are implementing the collection interface, it can use the add method. So here also we will be using add method. I'm adding 101. So 4 items I will be adding to the linked list. Same way, and then I will be printing the linked list using system.out.println and printing the object LL here. So we are printing here the array list and here the linked list. So when we print object, all the object values will be printed on the output screen. So here the linked list is printed. Now the difference between array list and linked list is array list will be storing the elements in the form of array, and we can increase or decrease the size of array list, and that's why it is a dynamic array. So it will be storing the data in the form of objects, plus we can increase or decrease the size of array, and sequentially it will be storing the data elements. Whatever data or objects we are adding will be stored sequentially, whereas in case of linked list, they may be stored randomly, and one item will be linked to another using the address of another item. So the elements are linked to each other using the address of elements. So they may not be sequentially stored. The first item will be linked to second using the address of second. So as they are linked to each other, it is called linked list, and it will behave like a list, and also it behaves like a queue because it implements the DQ interface of queue interface of collection framework. So this way we can create linked list object and add items to it. So we have seen array list and linked list classes which implement list interface. Linked list also implements the DQ interface, so it also contains the features of queue, and also it contains the features of list as it implements list. Next, we will be seeing the vector class which is implementing the list interface. So vector is same as array list. It is also storing the elements as array, but the vector supports synchronization, which is not there in case of array list. That means the predefined methods which are provided by vector are synchronized and can be used by a single element or at a time. They cannot be used by multiple elements at a time. So the resources are synchronized in case of vector. So let's see practically. So after array list and linked list, we can create vector class object. So which I am creating as V. So I am using same type, that is integer, for all the 4 classes. So even for vector, I will be using the integer type, that is integer vector wrapper class as vector type. And to use this vector, we need to import Java util package vector class in this manner. And we can add elements to vector. We can use add method, or so here I'm adding 1. So I will be adding 1, 2, 3, and 4. And to print it same way, I'm using println statement and printing V. So when I execute program, all the vector elements will be printed. So after we have seen the vector class practically, we are left with the stack class, which implements list interface. So stack will be following LIFO, that is last in first out method. That is, the elements which are added first will be removed last, because stack will be having only one end. From top we will be adding the elements and removing the elements. There is only one end. As a stack of records, the elements are stored in the stack format, so there will be only topmost one end. So we will be adding elements from the same end and removing elements from the same end. So last in first out format it will be following, and let's see it practically. So now we will be creating object for stack class. So stack will be following last in first out method, that is elements which are last in will be first out, first removed. So stack object as S I am creating. Also for stack I am using the type as integer. And I will be adding 4 integers to the stack. Now to use stack also we need to add the util package stack class. That is, we need to import java util stack, java.util package.stack class. So as all the collection classes are present in util package, java util package. So I am using here s.add. We can also use push method to add items to stack, but I am here using add for now, because add is the common method for all the collection classes. We can use with any of the collection classes add method. So all the classes which are implementing collection interface can use add method. So I am using here 11. So 4 items to this also I'm adding as 11, 12, 13 and 14. And I will be printing the stack elements same like other classes using println method. So I'm printing S object of stack class. So when we print object, it will print all the object values. So like this, we can make use of ArrayList, LinkedList, vector and stack. Now the differences is ArrayList class, LinkedList class, vector and stack will have their own predefined methods which can be particularly used on that particular class. So the stack, as it is stack and it follows last in first out method, we can use s dot like, because it has only one end. We have the methods like we have peek, pop, push. So using push also we can add elements. Using pop we can remove any element. So it will remove from top any element. So now if I print, I will be getting, so here s dot push, that is stack dot push 22 I have done. So it will be adding 22 to the stack. Now soon after adding I have used pop, so it has removed it also. So as it is last in first out. So first I will print and then I will again print. So first it has printed 22, because we have used pop again, it has removed 22 again. So last in will be first out. With these two methods we can see that. And then vector is same like an array list. Only thing is it supports synchronization. So we can use all these methods, add using index. Sorry. So we can check whether it is empty. We can remove any object or item. We can set a new size of it. We can get its size. We can sort the elements using comparator. So all these predefined methods can be used on vector objects. Same way, when I use this linked list, we can use, other than array list, we have add first, add last element in case of linked list. So we can add as the first element using add first method, add last method as the last element. And so these two methods are not there in array list, add first and add last. Also there are offer, offer first, offer last, peek, peek first, peek last, poll last, pop and push type of methods which are not present in array list. So because linked list also implements the DQ, these are the methods which are additional in case of linked list because it behaves like a queue and also a list. And then the array list can also use these methods like add using index, add all, the collection, complete collection we can add to the existing one. We can check if it contains certain object, and so all these methods, predefined methods, we can use on the array list objects. So when we store the data in the form of objects, we can make use of all these predefined methods to perform operation on the objects. So that is about list interface classes. So we have seen all the classes which implement list interface. So next is the queue interface, which is implemented by the classes PriorityQueue and ArrayDQ. So the DQ interface implements queue interface, and DQ is then implemented by ArrayDQ interface. So let's see how to use PriorityQueue and ArrayDQ of queue interface. Now in case of queue interface in Java, it follows first in, first out approach. That means whatever element we are adding first will be removed first. So first in, first out concept is followed, and there will be two ends for the queue. That is front and rear. So from one end we will be adding the elements, from the other end we will be removing elements. So that's the reason first in, first out approach we follow. So first we will be seeing array DQ. DQ here is double-ended queue. In case of array DQ, from both the ends we can add the elements, and from both the ends we can remove the elements, unlike priority queue, which we will be seeing. So first we will see practically how to create a array DQ. We will be creating an object for array DQ. So array DQ class followed by the object name, which I am taking as AQ, and equal to new array DQ. So this way first we create object for the array DQ class, and then we can mention the type of data which we want to store in this. So the type of data is mentioned using wrapper classes. So here I'm using integer wrapper class. So both the sites we need to mention it. So array DQ object we have created, which is of type integer. Now to this array DQ we can add elements using its object. So AQ dot, you can use any of this add, add all, add first, add last methods to add the elements. So add I am using for now. So add 55. Similarly AQ dot, so I am adding here some 4 elements. So AQ dot add 55, 66 and then 77, and then AQ dot add 88. So I have added here 4 elements, and then to display it we can just use system dot out dot println. So we can make use of iterator class, list iterator, or other cursors. So that we will be seeing later in this video. So here we are printing ArrayDQ using simple println function. So here when I run this, I will be getting all the ArrayDQ elements printed. So that was ArrayDQ in a Java program, and then we will be seeing PriorityQueue, in which we can add elements according to our priority. So for adding elements, we can follow the natural adding process, which is first in, first out, based on the priority of elements, or we can also use comparator to add elements. So to decide the priority of elements. So in case of priority queue, we follow first in, first out approach, and only from one end we can add elements, and from other end the elements are removed. Whereas in ArrayDQ, from both the ends, we can add elements and remove elements. But in priority queue, we can add elements only from one end and remove from other end. And here the elements are added based on priority. So let's see it in practical in Eclipse IDE. So in same way, we can create a priority queue object. So again, to use this priority queue in the program, we need to import. So you can import the priority queue class from Java util package before using it in Java program. So priority queue object I'm creating as PQ, and same way I will be taking integer type for it, like I have taken for ArrayDQ. So same this integer type, that is using this integer wrapper class, I will be giving the type of priority queue. And then I will be adding to this priority queue elements of type integer. So I'm adding here 90, 80, 4 elements. To this also I'm adding using the add method, which is common for all the collection framework classes. The classes or the interfaces which implement collection interface can use add method in common to add the elements. So now I will be printing using the println method, the predefined println method, the PQ, that is priority queue. And when I execute this program, I get 60, 70, 80, 90 displayed. And in case of priority queue, it sorts the elements while displaying. So we have added it in 90, 80, 70, 60, the different order, but it has sorted it in ascending order. So it sorts the element while and it does not maintain what order which we are inserting. So ArrayDQ, it is double-ended queue. So in this, from both the ends, we can add or remove elements, whereas priority queue has two ends, but only from one end we can add elements. From other end, we can remove elements. First in, first out concept it follows, whereas in case of ArrayDQ, we can add or remove from both the sides. So that was priority queue in practical. So next is the set interface of collection framework. Set interface is implemented by the classes HashSet, LinkedHashSet, and TreeSet, which also implements sorted set interface. So set interface also implements the set interface. And set interface in Java, it provides the features of mathematical set in Java. It cannot contain duplicate elements, unlike list interface, and we cannot create objects from the set interface, but we can create objects from the classes that implement set interface. That is HashSet, LinkedHashSet, and TreeSet are the classes for which we can create objects. So first we will be seeing the HashSet class in practical in Eclipse IDE. Create object for the HashSet. So I'm creating object for HashSet as HS, and then to this object HS, I will be adding elements. Now before adding elements, I need to also give the type So I am using the wrapper class integer to give the type of HashSet, and both the sides we need to mention type here like this. And then to the object we can use add method or other methods which are supported by HashSet, which can be used by HashSet. That is add all, the collection. We can add all the collection objects like that. Um, so the common add method I'm using here. So I'm adding an integer as 10. Similarly, 4 integers I'm going to add to this hash set. So integers are nothing but the whole numbers. So the wrapper class integer we use for giving integer type. And to print it, I'm using here system.out.println for now. Later we will be seeing the cursors to traverse this. I will be getting all the elements of hash set displayed. Now you can observe here, it is not maintaining the order of insertion. It will randomly store the elements. So 10, 25, 5 and 4 is the order, but it is 4, 5, 25, 10. The order is different. It is not sorting the elements, but it is not even maintaining the insertion order, the hash set. So that was hash set in practical, and then we will be seeing next the linked hash set, where every item is linked to the next item or other item using its address. So after hash set, linked hash set object I'm creating here in the same way. Sorry, not linked list, linked hash set. And we can then use it in our program. So for linked hash set also, I am taking integer type only. So I will be adding integer type data to linked hash set. So the object name is ls, the common add method I'm using to add the elements. So I will be copying this and adding here. I will just change here the object name ls. So the same elements I'm adding just to see the difference between linked hash set and hash set. So here in the same way, the same elements, same like hash set I have added to linked hash set. Now when I run this, I will be getting the elements in order. So you can see hash set is not maintaining the insertion order, whereas linked hash set, where each element is linked to another, uh, it is maintaining the insertion order. The order in which we are inserting the elements is maintained in case of linked hash set. And these set classes, all the classes which are implementing set interface, will allow you to perform union operation, intersection operation, or union all operation. So we can perform or we can perform the set operations on these classes. So that was linked hash set, and hash set will not maintain insertion order. Linked hash set will maintain the insertion order, the order in which we are inserting the elements. Now next we will be seeing the tree set, which implements not just set interface but also the sorted set interface, which implements set interface. So as it is implementing the sorted set interface, it also sorts the elements. So let's see how to use this tree set in Java program. Same way like how we have used hash set and linked hash set, we will be using here tree set. So for that also we need to create object for it. So I am creating as TS, the object of tree set. Linked hash set and hash set, I will be adding same elements. I will just change the object name. So I will change the object name to TS, but adding the same elements like hash set and linked hash set. So this way I have added to the tree set all the integer elements. Now we are getting some warning because we have not mentioned the type. So I'm mentioning the type as integer here. So now if I execute or run the program, then I will be getting all the elements in sorted order. They are sorted in ascending order. So you can observe here the hash set is not maintaining insertion order, and also it is not sorting the elements. So it will not sort elements, and it will not maintain the insertion order. That is, it will not maintain the order in which we are inserting elements. Whereas LinkedHashSet, it will maintain the insertion order, but LinkedHashSet also will not sort the elements. It will not sort the elements, but it will maintain insertion order. Whereas in case of TreeSet, it will not maintain insertion order. Whatever elements we are adding, it will sort it in ascending order and then display. So TreeSet, as it implements the sorted set interface also, it sorts the elements which we are inserting. So that was TreeSet of set interface. So we have seen in practical HashSet, LinkedHashSet, and TreeSet. As we have completed with the list, queue, set, and map interfaces of collection framework, next we will be seeing the cursors which we will be using for traversing the data present in the objects which we create using these classes. So to retrieve the data one by one, to retrieve elements one by one from the object stream, we will be using the cursors, which we will be seeing next. From the collection object, to retrieve object, we can use the following three cursors, that is Iterator, List Iterator, and Enumeration. So these three cursors we can use to retrieve the element or object from the object stream. So we will be seeing first how to use Iterator interface to traverse the collection classes. So in this program, which is in Eclipse IDE, so here is the program where we are using the ArrayList, which implements list interface of collection framework, and HashMap, which implements map interface of collection framework. So the difference between ArrayList and HashMap is ArrayList will be implementing list interface, which implements collection interface of collection framework, whereas HashMap implements only map interface, which is part of collection framework. It does not, map does not implement collection interface. So these two classes we are using, on which we will be making use of Iterator to traverse its elements. So to retrieve the elements of ArrayList and HashMap, we are here using the Iterator interface. So you can see here I have created the object for ArrayList, which can store integer type of elements. So here there are 4 elements of type integer, and here in the normal manner, that is simple way, we are printing the ArrayList using println method. So when we print using the println method, all the elements together like in the set format, it will be displayed in the console. Whereas we can use Iterator in this manner, that is, first we can create object for Iterator into which we can hold the all ArrayList elements using Iterator method with the ArrayList. So al.iterator will get all the elements into ITR1, and then we are checking if the iterator has next element using the has next method of Iterator. So Iterator is the cursor which is used to retrieve one by one object elements. And here, if it is having the next element, then we are printing the next element using while loop. So till it has next element, it will be printing every time the next element. So this is in case of ArrayList. First, we are creating an iterator object into which we are taking all the ArrayList elements, and then we are checking if it has next element and printing every time the next element. Then we are using the HashMap. So this statement will just print HashMap as the heading, and then here we are creating an object for the HashMap of type integer and string, that is key value pairs it can hold. When we are using maps, it will always hold the entry in the form of key value pairs. Each key can point to a value. So here keys are unique, values may be duplicate. So here I'm using 4 keys with 4 values which are pointed by these keys, and then printing using println method the hash map. So all these values together will be printed as a set. And then here I am using the set class, which is a default class, creating object for it for like a hash map entry, that is HM entry, into which I will be taking all the entries which are in the form of key and values. That will be called as entry set, that is in the form of entry set. So using this entry set method, we can get all the key value pairs into this object. So set object is now containing all the key value pairs. Now this set can be iterated or traversed using the iterator, using iterator method, which we are getting into iterator object, and then checking whether it has next element, and then using again here the map dot entry, the default type object E, into which we are converting this, every entry we are converting into map dot entry, this form, so that we can get values and keys separately. So this we are doing to convert it, each entry into values. We can get the values and keys separately or together also. So I'm converting it into map entry form, and then I'm printing each element. So when I execute this, I get array list elements together first. This is due because of this println method, and using iterator we can get it separately one by one. Same with the hash map. When we are using println, we are getting together all elements. If we are using the map entry form, that is using iterator, we are getting all the map entries in this manner. We can even get e dot values or e dot keys, only keys or only values, like so e dot only get key. So only get key. So only keys will be printed using get key method. It will get you the key values. Similarly, you can get the values also. E dot get value. So if I execute, I will be getting only keys and values separately. So these are the keys, and then this is the value. So because I'm using the loop, key, value, and then together entry, E, key, value, and the entry. So like that we are getting. So we are getting entry and then key and value, entry, key, and value, entry, key, and value. So this way. So using iterator, this way we can traverse or retrieve the elements from the collection objects. Next, we will be seeing list iterator. So iterator we have completed. How to use iterator with the collection classes we have seen, that is with the classes that implement list interface or map interface we have seen. Now next we will be seeing the list interface. Sorry, list iterator, which is used to traverse in the same way like iterator, but there is slight difference between list iterator. That is, iterator can move only in one direction, that is only in forward manner. We can remove or traverse only in forward direction, whereas in case of list iterator, in backward and in also forward, it can traverse in both the ways, forward or backward. So iterator has got remove method, has next method, and for remaining method, whereas list iterator has next method. It also has previous and has previous method. So we can check or traverse in backward and also in forward direction respectively. So iterator, both the ways it can traverse, whereas iterator only in the forward direction. So let's see list iterator. So here we are in Eclipse IDE where we have a program, Java program, where we are using the ArrayList. ArrayList that implements list interface of collection framework. So to use ArrayList, we need to first import the ArrayList class from Java util package. And now because we are using list iterator, that also we need to import from Java util package. So here I am creating the ArrayList class object to which I am adding the integers and printing using println method all the ArrayList elements to the console. Next, I am using the list iterator object into which I am taking all the array list elements using list iterator method. So using this list iterator method, we can iterate through the array list, which can be held in list iterator object. Now we are checking whether the list iterator object has got next element. And if it is having next element, then using the next method of list iterator, we are displaying it using the while loop. And when it has no next element, then we will stop. The loop will stop execution. Same way, because list iterator can work both in forward and backward direction, we are here using the has previous method. Whether it is having the has previous element, we are checking and then printing every time the previous element. So this is in forward direction and this works in backward direction. Whereas in case of iterator, it works only in forward direction, not in backward direction. It has no has previous or previous method. Only list iterator has got these methods, has previous and previous to check in previous or sorry, backward direction. So if I'm executing this program, I will be getting the elements displayed in forward direction, and then this is the reverse direction, that is backward direction. So list iterator can be used in both the ways to iterate through forward and backward direction. So now here is the Java program where we are using the enumeration cursor. So enumeration, it is an interface which can be used with legacy classes like vector, stack, and hash table and all to traverse the elements in forward direction only. Uh, it is used with legacy classes and it was superseded by Iterator. So it is not obsolete. It is still used, but sorry. So it's considered obsolete for new code, but however, still it is used by several methods of legacy classes like vectors and stacks and hash tables. So properties, several API classes use this enumeration interface for traversing the elements. So enumeration is synchronized and it does not support adding, removing, or replacing elements. And we can access the elements only in forward direction using enumeration. And legacy classes have methods to work with enumeration and return enumeration objects. So here we are using vector, but also we are using here array list in which we are using enumeration. So vector object I have created and added elements to it, 4 elements of type integer. And then I'm printing here the vector using println method. Then I'm using here enumeration to traverse the vector elements. So first I'm creating enumeration object into which I'm taking the vector elements. And then in the while loop, I'm checking if enumeration E has got more elements using has more elements method of enumeration. And if it has more elements, then the next element method can be used to display the next element, each next element. And when it has no more elements, then the loop will stop execution. Similarly, if you want to use the enumeration with array list, So here ArrayList object created to which we have added integer type of elements, printed ArrayList using println method, and then here enumeration we have created object. Now here ArrayList directly cannot be used with enumeration, only legacy classes can be used. So here we are using the enumeration method of collections to convert it into enumeration type. So here the ArrayList is typecasted into enumeration type and then casted into enumeration type, and then we are uh, checking whether there are more elements in E1, that is enumeration object, and then printing next element of enumeration. So we can enumerate the elements of array list and also the legacy classes using enumeration, but it is considered obsolete for the new code, but still it is in use. So enumeration is also one of the cursors used in Java collections. So enumeration, list iterator, and iterator we have seen practically how to use to traverse the Java collection objects. Iterator can traverse only in the forward direction. List iterator can traverse in both forward and backward direction. Enumeration was there to be used with legacy classes. It was there introduced before iterator. So iterator mm, was introduced after enumeration, and it is used with new code, whereas enumeration is considered obsolete for new code. So enumeration can also be used only in forward direction with legacy classes. So these are the three cursors used with Java collection classes. Next, we will be seeing how to sort the collections using comparable and comparator interfaces. So we have seen cursors of Java, that is iterator, list iterator, and enumeration. Next, we will be moving to the sorting in collections using comparable and comparator interface. So next we will be seeing how to sort the collection objects. So sorting and ordering of collection objects we will be seeing, which will be done in case of collections using comparator and comparable interface. So comparable and comparator interfaces are used for sorting objects, collection objects. And the difference between the two is, in case of comparable, it provides single sorting sequence. So that means we can sort the collection on the basis of single element or single parameter such as ID, name, or price, or age, like that. On the basis of single parameter, we can sort the collection. Whereas in case of comparator, it provides multiple sorting sequence. That means we can sort the collection on basis of multiple elements. So we can use ID also, name also, age also, or any parameter of the class to sort the collections. Then when we are using comparable, it affects the original class. The actual class will be modified. It affects its own instance. And when we are using comparator, it will be used on other classes. It will not affect the original class. We can use comparator for comparing the objects of other classes, not its own instances. And then comparable provides compare to method to sort the elements. The method compare to is used for sorting the elements, whereas in case of comparator, we use compare method to sort the elements. And in case of comparable, the interface, to add this interface, to use it in our program, we need to import it from java.lang package. So it is present in java.lang package, whereas comparable is present in java.util package. So we need to import, in case of comparable, java util package. And then we can sort the elements, the list elements, of comparable type by using collections dot sort method, which takes a single parameter of type list. Whereas in case of comparator, we can sort the elements by collections dot sort method, which takes two parameters. One is of type list and the other is of type comparator. So here it takes two parameters, whereas in case of sort method of comparable, it takes only a single list parameter. So that's the difference between comparable and comparator. And now we will be seeing the difference practically in Eclipse IDE. So this one here is the Java program in Eclipse IDE. And here we are using an array list with three items or three objects, we can say, which has properties like the ID, name, and age. So it has three data members, ID, name, and age, each object. So now we will be sorting these three objects based on age using a comparable interface. So we have here two classes in this file. The class test contains the main method where we are using the array list. We are creating array list and sorting it. Now for sorting it using comparable, we have first created here the class student that implements comparable interface. So class student that implements comparable interface. And here the student class is having three members, data members, roll number, name, and age. So we will be using the default compare to method. We will be overriding here compare to method of comparable to compare the age of student. So whatever age we will be passing to this compared to method will be compared with the age. And if it is equal, then it will return 0. If it is greater than the past age, then it will return 1. And if it is less, then it is returning -1. So based on this manner, we will be comparing the two objects using compare to method. And this compare to method will take only one parameter, that is the object of the same class. So we will be using its own object, that is it can be used on same class instance. And in the main method, we have created array list of three objects. The three objects here, the array list is of type student. So student type object, we have taken three objects on which we will be applying the sorting method. So while using comparable, as we have seen, we use sort method that will take parameter of list type, a single parameter. So we will be passing the list, that is array list, to sort method of collections, and it will be sorting the list, array list, based on the age, because we have applied here or comparing here based on age. So it compares only the single object at a time, single instance at a time, single parameter at a time. So it is a single sorting sequence because it is comparing based on single element, like here in this case age. So it is not using more than one element. Based on a single element, it is comparing the list. And for comparing it or sorting it, we will use sort method. Comparing it, we use compare to method, and it compares its own instance. It will be affecting the class which is implementing comparable. So the class which is implementing comparable, its object only can be compared. So this way we use comparable interface. So for using array list, we have here imported ArrayList class, and for using the sort method from collections, that is here we have imported collections from Java util package, and here we are implementing the comparable interface for student class, and then we are using or overriding here the compare to method where we are comparing the age of student, and it is returning 0, 1 or -1 based on the comparison. If it is equal 0, if it is greater than the passed age, it is 1, and if it is less than -1. So this way, the sort method will sort the array list, which is passed here to the sort method, based on age, which is compared using compare to method of comparable interface. So this way we can use comparable interface for comparing a single parameter or single element of a list, and we will be comparing it and sorting the list. So class implements comparable, compare to is overridden, sort method is used for sorting the list. So while using this it will be uh, comparing it, and based on this comparison the list gets sorted. Next we will be seeing the comparator interface. So we have seen in practical comparable interface, which provides single sorting sequence, affects the original class, that was student in our case, and it uses compare to. So we have used compare to for comparing the age, that is single sorting sequence, single element we were using for comparing, and the comparable interface present in Java language package. So we were using the sort method from collections and with a single parameter list, to which we have passed the array list of type student. Now next we will be seeing in practical comparator. So here is the Java program where we have created an array list of type student. So student class we have created separately here with 3 data members as roll number, name and age. And here is the constructor which will be initializing these 3 instance variables of student class. And on this student of this student type, we have created a array list. So each member has 3 parameters, that is roll number, name and age. So 3 objects we are storing in this array list. Then now we will be sorting the array list using the comparator. So here in this program we are using comparator interface. So comparator interface can be used on 2 elements of different classes. It can affect the other class. Um, so it provides multiple sorting sequences. So based on multiple elements, like we can use roll number or name or age to sort the list. And it will not affect the original class, and the original class is not modified, because here we will be using the student class. We will be using it to compare or sort the array list elements of student class. So array list is of type student. These based on name or age, we will be sorting it. So we have created a separate class age comparator for comparing the age of students, and we have created a name comparator for comparing the names of student type. So here we are comparing the element of different class, but here the age comparator implements comparator, and it is used on student class elements, student age. That means, and here name comparator, a separate class we have created which implements again comparator, and it also works or compares the student's name. So the names of student class will be compared. So we are using compare method to compare the ages, and here compare method to compare the names of student. So we will be passing 2 parameters to this compare method. So S1 and S2, 2 objects we are passing, which are compared, and based on their equality or whether they are uh, not equal, if first stage passed is greater than the second, it will return 1, and else -1. So these are the comparisons we are making. And here 2 names are compared, and based on the comparison, it will return the result, whether they are equal or not. So it will be comparing the names here using name comparator, and we are comparing ages here using age comparator class. Both the classes implements comparator, but it is working on this class, a different class, which is not implementing comparator. So we are here using two elements, name and also age, for comparing. So first here we are sorting the array list by name. We are sorting the array list by name, and we are using here sort method, to which we are passing the array list and the comparator, name comparator. So as it accepts two parameters, the sort method will accept two parameters. So here we are passing the list. The first parameter is of list type, the second is of type comparator. So here we are passing the name comparator. And the list, the array list, will be compared based on the name, and it will be displayed. So names in ascending order, it will be sorting and displaying it. Whereas here we are comparing by age. So again here to the sort method we are passing the array list, and now this time we are passing the age comparator. So object of age comparator here is passed, and then we are sorting it based on age, and it will be displayed using this for each loop. So when I execute this, I will be getting the result displayed, which is for the first time compared by name. So here it is sorted by name. You can see Anna, Sonam, Tia. So the letters, the first letter in ascending order, it is arranged. Whereas in case of age, the ages in ascending order, they are displayed 22, 25 and 27. Whereas while adding to the list, we have given this order. Were not Sonam, Anna and Tia, which is not the order displayed. This is the sorted order, Anna, Sonam and Tia, as it is sorting the names in the first place. Here in the second, it is sorting the ages. So this way we can use comparator on different on other classes which are not implementing it, and we can compare it based on multiple uh, elements. Like here in this case, we are comparing it once by name and the other time by age. So we can use any number of multiple elements, any number of elements to compare or sort the list. So for sorting of collection objects, we use comparator, and we have also seen comparable. So this way comparator is used in a Java program for multiple sorting sequence, which in our case was for uh, we were sorting the list using name and also by age. So multiple elements we have used for sorting it, and it will not affect the original class. That means the age comparator and name comparator were implementing the comparator interface, but it was used on a different class, that is student. And comparator provides compare method to sort elements. So compare method we were overriding for sorting the elements of array list, and sorting the elements based on the elements age or name. And then comparable is present in Java util package, and we were using the sort method, which will be taking two parameters of list and comparator type. So we were passing the array list and age or name comparator for comparing it by name or age respectively. So this is so this way we can use comparable and comparator for sorting the collection objects for single sorting sequence or multiple sorting sequence. So thank you for watching the video, and please do like, share and subscribe the channel for more updates on Java.